All right, so I think this is recording. Let's take a look here at number 9. We want to solve this triangle. They give us half the information, and we need to come up with the other half. We need to determine the measure of angle A, the measure of angle C, and the length of A. So let's make a sketch of what they've given us. The measure of angle B is 12.6 degrees. The length of side B is 2.9, and the length of side C is 7.2. Well, this is our ambiguous case. We have two sides in the non-included angle. And the first thing that I wonder, this 2.9, is it even long enough to form a triangle? I need to find the height of this vertex. Because had the 2.9 been larger, had it been larger than 7.2, I would know that there'd be exactly one obtuse triangle. But right now, I don't even know if any triangle exists. I need to find this height. So the sine of 12.6 degrees is the opposite leg, that height divided by the hypotenuse of 7.2. If we multiply both sides of the equation by 7.2, we'll determine, we're going to compare this height against this 2.9. So let's come in and take this 7.2 times the sine of 12.6. Now, wait a minute. I forgot to check that if I was in degrees or radians. By default, when you reset the memory on the calculator, it goes to radians. So yeah, 1.57. So this 2.9 definitely covers that distance. So we're going to have, since 2.9 is smaller than 7.2 but larger than 1.57, we're going to have two triangles. So I'm going to erase this. And what I'm saying, if we think of this vertex as a hinge and this 2.9 like a pendulum on a clock, when we swing it out this direction, that's forming this triangle. Well, what we can also do is take this and swing it in all the way to the left of this height, and we would have a triangle that looks like this, because this guy is swinging up to this point. So in the top triangle, let's get a highlighter. Here's our triangle here, and now in this one, the triangle is here. In both of these triangles, B and C are the same. They don't change. But this A, the measure angle A, the measure angle C, and the length of A are different in each of these triangles. That's why there's two possibilities. So let's jump in, use the law of sines. Let's start with our known pair. We got a pair of B's. The sine of B over B is going to be equal to the sine of C over C. We want to use the length that was given there. So we've got the sine of 12.6 over the length of 2.9, and we don't know this angle measure for C. Remember, C is here. Well, it's here and here. So we do know the length of side C, 7.2. So let's jump in, use the calculator, and get this ratio, and then use that ratio to find the measure of angle C. So if I have 7.2 times the sine of 12.6, close that parenthesis, and then divide it by 2.9. Now, be careful. This is not the measure of angle C. This is the ratio. I have to take the inverse sine of that answer. My angle is 32.79. And we kind of know that the calculator isn't telling us the full story. The calculator is giving us an angle that has a measure between negative 90 and positive 90. Well, in these applications, we're not going to have negative angle measures, so it's giving us a quadrant 1 angle. And we know, going back to that ratio, that was the 0.54, whatever it was on the calculator, that there's two places on the unit circle that has a y coordinate with that ratio. And one's in quadrant 1. We found the calculator gives us that one, but we have to find this other angle ourselves. That's why it's producing 2, and that's why these problems, students find it a little bit difficult, because everybody expects the calculator to do everything for us, and it doesn't. We're going to have to treat this like a reference angle to find this quadrant 2 angle. But first, let's finish the information in triangle 1 and then come back to this quadrant 2 angle in just a second here. So if we continue, we can find that third angle super easily, because the measure of angle B, these three angles have to add up to 180. So if we take 180 minus the sum of the given angle, 12.6, and the angle that we just found, the 32.79, we have that triangle angle sum theorem that says, hey, the angles inside of a triangle always add up to 180. So we've got 180 minus the sum of 12.6 and 32.79. 134.61. 134.61 degrees. All right, so let's return to our law of sines. The sine of B over B, this ratio, is not only equal to sine of C over C, but sine of A over A. And I called this B, and I should have called it A, because B was given. That's why I'm hesitating here. It just didn't make sense that this is angle A. See, because I know the angle B. Sorry about that. So I've got the sine of 12.6 over this 2.9. And now I have the sine of 134.61 degrees over A. Now I'm going to have to shrink this up and come up, find some space on here over on the right to finish this. Well, I guess I've got room right there now. All right, so let's cross multiply. So along this gold diagonal, 2.9 times the sine of 134.61. Along the other diagonal, we have 12.6 times a, but we need to get this a by itself, so we'll immediately divide by the sine of 12.6, and what do we get? So we've got 2.9 times the sine of 134.61. Now, don't forget to close that parenthesis. Divided by the sine of 12.6. 9.46. So we found the measure of angle A, we found the measure of angle C, and we found the length of A. So we're done with our first triangle. Now, let's come back. I'm going to erase some of this. Come back to that point where we first used the calculator to find that quadrant 1 angle, because we know it didn't tell us the full story. It didn't tell us about the second. It treated it like a function, and it only gave one output. And we know there's two possible outputs. So we knew that it was possible for this angle C to be 180 degrees minus, we'll treat this like a reference angle, 32.79. $147.21. So I claim that if we take the sine of that 32.79 and compare this ratio of 0.54 against the sine of 147.21, they're the same ratio. It's the same number. So let's continue then. If we have this is, and let's call it C2 or something like that, so that because now we're finding the information on the second triangle down here. So by our triangle angle sum theorem, we know the measure of angle A, the second A, is 180 minus the given angle of 12.6 degrees plus this 147.21 degrees. Let's see what this is. 180 minus the sum, because we have that angle, the triangle angle sum theorem from geometry. 20.19. So now we have our three angles. Let's come in and find that missing side. So we come back to that given pair, the sine of B over B, and this time we also know not only is it equal to the ratio sine of C over C, but it's equal to the ratio of sine of A over A. So all right. We know we have the sine of 12.6 degrees, the length of 2.9 units is equal to this ratio of the sine of 20.19 degrees over the length of A. So if we cross multiply, along the gold diagonal, we have 2.9 times the sine of 20.19 degrees. Along the green diagonal, we have 12.6 times a, but we need to get that a by itself. So instead of multiplying by sine of 12.6, we immediately divide it. And this is going to tell us the length of a, and we'll be done. I'm getting 4.9 units. 4.59, excuse me. All right, so there's our final answer, and I hope that helps. I'll talk to you later.